Hello friends, welcome to Civil Engineering Exam. Today we are going to see the problem related with foundation engineering in the topic of well foundation. So the problem is a circular well 6 meter external diameter and 4 meter inner diameter is embedded to a depth of 15 meter below the maximum score level. Okay, in the sandy soil deposit, the well is subjected to a horizontal force of 800 kilonewton acting at the height of 8 meter above the score level. Okay, so now we can draw the well diagram. So this is the well. Okay, so this is the score level. So this is a core level. So the height above the score level is 8 meter. The height below the score level is 15 meter. Okay, so then inner diameter of the well is 4 meter. Then outer diameter of the well is 6 meter. Okay. So now the h will be 8 meter. So the h will be 8 meter. So the h1 value will be 8 plus 15, that is 23 meter. Okay, so the pressure will be distributed like this. Here is P. So now we have to determine the allowable total equivalent resting force due to earth pressure, assuming the rotation is about the point above the base. Okay, so then unit weight is given, gamma saturation is 20 kilonewton per meter cube, then phi angle of internal friction is 30 degree, then factor of safety is 2. So we have to use the Terzaghi analysis. So first thing is we can find out the Ka and Kp value. So that is coefficient of active earth pressure and coefficient of passive earth pressure. So now the formula for active earth pressure, coefficient active earth pressure, 1 minus sine phi divided by 1 plus sine phi. Okay, so now we can substitute 1 minus sine 30 degree divided by 1 plus sine 30 degree. So solving this we got the value of 0.333. Okay, so now Kp value, so Kp is 1 divided by Ka, so that is equal to 1 divided by 0.333, that is equal to 3. Okay, otherwise we can calculate from the formula 1 plus sin phi divided by 1 minus sin phi. Okay, so now we found out Ka and Kp value. So now we can find out the equivalent force. So before that we can find out the H1 value. So now H1 is 8 meter plus 15 meter, so that is equal to 23 meter. Okay, so next thing is we can find out the D1 value. So now we can use the formula to D1 equal to 3 into H1 plus or minus root of 9H1 square minus 2D into 3H1 minus D. Okay, so this is the formula we can use to find out the D1 value at the rotation above the base. Okay, so now we can substitute all the values over here. So 2D1 equal to 3 into H1 value is 23, again plus or minus 9 into 23 square minus, here D is 15 into 3 into 23 minus 15. Okay, so here the only unknown is D1 value. So solving this we got the value of D1 equal to 6.48 meter. Okay, so we found out the D1 value. So after that we can find out the Q max. After that we can find out the QA. Now we can use the formula for Q max. So Q max equal to the formula 1 by 2 half into gamma into D into K P minus Ka into D minus 2D1. Okay, so now we know all the values. So now 1 divided by 2 into so gamma value is gamma dash value is 10. Why? Because so gamma dash equal to gamma saturation minus gamma W. So now gamma dash equal to gamma saturation is 20 is given minus gamma W value is 10. So gamma saturation equal to 10 kilonewton per meter cube. Okay, so again into D value. So D value we know the 15 into Kp value is 3 minus 0.333 into D value is again 15 minus 2 into D1 values we found out 6.48. Okay, so solving this we got the value of Q max equal to 408.1 kilonewton per meter. So next thing is we can find out the QA, that is allowable transverse load. So now Q max into length divided by factor of safety. Okay, so Q max is 408.1 into length is 6 divided by factor of safety is 2. So solving this we got the value of 1224.2 kilonewton. So this is the final answer. So this is the method we can solve the problem. Again we'll see next video. Thank you.